Okay, all good? Fantastic. Okay, so for the last sort of 10 minutes or so, I want to introduce this newer idea. So, are you happy that so far we've looked at, I think, 3 different ways that we can combine vectors together? Okay, so let's recap. First way that we can combine vectors together is through addition or subtraction. Okay, so we can combine vectors together, let's say A and B. Okay, we can combine them together through addition or subtraction. In other words, we can find A plus B or A minus B. Okay? Now just remind me, what is A plus B? What geometric, how does that look geometrically? A plus B?
I mean, go to A, then go to B.
Absolutely. Move along A, then move along B. What does A minus B mean geometrically? Exactly. Move along A and then move along the reverse direction of B. That's what subtraction literally means, yeah? Then we've looked at multiplying by a scalar, okay? Now a scalar is simply just a number, okay? So you're happy a vector is a quantity that has magnitude and direction. A scalar just simply has magnitude. It's just simply a number, okay? So, we've looked at multiplying by a scalar. In other words, we can now do some multiple, for example, 3 lots of A. Okay? So if it was 3 lots of A, or k lots of A, just simply means move in the direction of A, but do that k times. So move along A, then A, then A, then A, and keep doing that. Okay? So this vector should be parallel to A. Makes sense? Okay? Now what's missing?
If you square it?
So if you square it, isn't that just multiplication? Repeated multiplication, yeah? So we haven't looked at multiplication. Now actually, we haven't looked at division either, and we won't, because division doesn't have a geometric sort of equivalent. Okay? You can't really visualize it equivalently. So dividing vectors by each other doesn't make sense. Doesn't make sense, okay? So, multiplication. Now, unluckily for you, there are 2 types of vector multiplication, and you have to know both. So the first type is called the scalar or the dot product. So don't mind whether you call it the scalar product or the dot product. Okay?
Which is like multiplying 2 different vectors, or like...
We'll see. We will see. Yeah? So you're multiplying 2 vectors by each other. You're doing like A times B, or A dot B in this case. Okay? Now interestingly, because it's a dot product, okay, we literally write it as a dot. Are you happy that sometimes, for example, if I want to do, I mean, you've seen it when I do this. Okay? Sometimes when I write multiplication, I don't want to write it as a multiply sign, like that. I write it as a dot instead. Okay? So I use one of those, so I use a dot if I'm doing the dot product. So for example, if I'm doing A dot B. Okay? And I emphasize the dot to show I'm doing the dot product. Okay? The other type of product, the other type of multiplication I can do, is known as the vector or the cross product. So again, I don't mind whether you want to call it vector product or cross product. Okay? And because this was a dot product, I write a dot here. Because it's a cross product, I literally write a cross. So my traditional multiplication. Now you've got to be aware here, these are 2 different types of products. These are 2 different types of multiplication. This means one thing, and this means something entirely different. Okay? Now, interestingly, the result of each of these 2 operations is either a scalar or a vector. So if I do this one, if I do the dot product, it means the answer will come out as a number. It will come out as a scalar. If I do this one, which is the cross product, it means the answer will come out as a vector. Okay, so that's another difference between the 2. So, just because we're slightly short on time, I'm just going to give you what the scalar product is, and we'll look at the vector product on Monday. Okay? So, a scalar product is like this. If I have 2 vectors, so A1, A2, A3, that's A. Okay, so that could be like 3, 4, 7. It's just first component of A, second component of A, third component of A. And the same for B. B1, B2, and B3. Okay? The scalar product is simply what happens if I multiply each corresponding component together and add them. Okay? So the scalar product, so A dot B, or the dot product, is going to be what happens if I multiply corresponding elements together. It's the first component of A by the first component of B, the second component of A multiplied by the second component of B, and the third component of A multiplied by the third component of B, and then add them all together. That is the scalar product. Okay? And can you see that this has to come out as a number? Yeah?
Yeah.
Has to come out as a number. There's no other way. Like, multiplying two numbers together, multiply two numbers together, multiply two numbers together, add three numbers together. It's got to come out as a number. It's got to come out as a scalar. Okay? Now, just because, I mean, if you're interested in the proof of this, there is a video online of me proving this for you. It's literally just the cosine rule. But an application of the scalar product is to find the angle between two vectors. Okay? So an application of the scalar product is to find the angle. Now, interestingly, I'm not going to give it to you today, but an application of the vector product, when we look at it on Monday, will be to find a normal vector.
I mean, what angle mean in that case?
Let me illustrate that. Okay, so let me illustrate that. A normal vector is just simply a vector which is perpendicular or at 90 degrees to both A and B. So if you imagine, like my fingers, okay, let's imagine my first finger is A, my second finger is B. You see that? First finger is A, second finger is B, okay? My vector product will be that one there, okay? My vector product will be my thumb. Does that make sense? So it's a vector which is perpendicular to both of them, okay? But what do I mean by the angle between two vectors? Well, look, if this is A, okay, and this is B, if I join the start of those vectors together, the angle between the vectors will be that one there. Okay, so it's literally the angle between those two vectors.
Wow, okay.
Okay? Now remember, this will apply in 3 dimensions, 4 dimensions, 5 dimensions, as many dimensions as you like. I'll always be able to find the angle between them. And this is how I find it. So once I define this, okay, the angle between the two vectors will be given as the cosine of that angle is given by the dot product of the two vectors divided by the products of their magnitudes. So literally this is just coming from the cosine rule. Again, if you're interested in this, I've put a video online deriving this. So by all means go away and have a look at that. I think it was done sort of about last June if you wanted to trace it back. Okay? But effectively, this is the core idea. The main use of the scalar product is to actually find the angle between the two vectors. So we don't just do it for the fun of it, we actually do it to find the angle between the two vectors, and this is how we do it. Okay, it literally comes from the cosine rule. Is that okay with everyone? Are there any questions?
No.
We'll look at an example on Monday, and then we'll go on to the vector products and cross products.